Hello guys, this is Mehak. So this is our project CSS Sport Performance Building Blocks for Group 2. This is my team, me, Mehak Kansal, Shamli, Darshana, Harsha and Arjun. So this is our project overview. The CSS Sport Performance Dashboard aim to enhance the performance of hockey players, which it focus on some factors like leadership, accountability and responsibility. It is to develop an interactive dashboard for athletes, parents and their coaches, and we are doing some data driven insights to track performance and improvement for the athletes. So this is our weekly status summary. We did in the week from week 1 to 6 we did some things like data collection, defining dashboard structure, data cleaning, EDA part, predictive modeling. Then we compare three models: random forest, logistic regression and name bias, to get the best model. Then we started working on building dashboard step 1 using Power BI. This is our current progress demonstration regarding the project. So dashboard prototype developed with initial visualizations, EDA completed with key patterns identified in there, and we are done with the predictive modeling too. Then we received feedback from the client as we gave the client top 3 performance matrices, and now we are preparing refined dashboard version for final implementation, and we are done with the test dashboard using Power BI. So over to Harsha. Thank you.
Hello everyone, thank you Mahek. So this is the data cleaning and missing values exploratory data analysis part of our data set. I will go through this in Python in a few minutes. And the key visualization and insights. The athlete performance trends are done across different regions, different sessions, and the performance comparison between different training weeks is also done. We have also done the predicting modeling for performance improvement, and in the predictive modeling, we have done the decision trees for leadership impact on performance. We have also done the comparative analysis of machine learning models. We took three models and we have done the comparative analysis, and these are the session 1, session 2 and session 3, session 4, session 5 visuals. I will walk you through all this in the Python file. So this is the Jupyter notebook. This is the dataset overview where we have the data types, the statistics, everything, and these are the missing values and duplicates. We have 0 missing values and 0 duplicates, and we have done the data cleaning. In the data cleaning, we have added the averages of all the all the sessions, and we have also added the improvements of each athlete for all the sessions. In the exploratory data analysis, we have done two EDAs, one for athlete-wise data and one for session-wise data. And we have done all the mean, median, skewness for exploratory data analysis, and these are the visualizations for session 1 to session 5. So in session 1, these are the improvement scores for session 1. So we can see the success rate improvement is the highest improvement, which has 57.89%. And this is the athletes showing improvement no improvement, and 89.5% of the athletes are improved and 10.5% of the athletes are not improved, have shown no improvement. And next, these are the pre and post scores of all the athletes across all the sessions. Of next, for the session 2, these are the improvement scores, and the highest is the leadership confidence improvement score. And here for session 2, 94.7% of the athletes show improvement and 5.3 show no improvement. And these are the pre and post scores of session 2 of all the athletes. In session 3, we can see almost all have a good improvement, but the highest is responsibility improvement in daily habits. And for session 3, these are the pre and post scores. For session 4, we have two variables. So this is the improvement score, and we have the best athlete improvement as 63.16, which is the highest. And for session 4, 89.5% of the athletes show improvement and 10.5% of the athletes show no improvement. And this is the pre and post scores for session 4. For session 5, almost all the improvements are more than 50%, and the highest is the communication abilities improvements for all athletes. And for session 5, we have 68.4% of the athletes who showed improvement and 31.6% who showed no improvement. And this is the pre and post scores of all the athletes for session 5. So overall, we had good improvements across all sessions for almost all the athletes. Over to Darshana. Thank you.
Thanks, Harsha. Hi, everyone. Today I'll be presenting the decision trees for performance prediction. One predicting the S1 performance using ethical leadership and athlete classification, and another predicting the S5 communication abilities based on leadership capability, and both effectively distinguishing performance level with minimal error. Next slide. Random forest and naive bias were considered for machine learning model performances. In this, random forest and naive bias underperformed due to feature selection issues, whereas logistic regression achieved 75% accuracy but struggled with class 1 identification. To improve the results, we have redefined the feature selection, balanced the dataset, and enhanced the prediction metrics to better support the athlete development. Next slide. This slide shows the Python code comparing the naive bias, random forest, and logistic regression based on the accuracy, precision, recall, and F1 score. Logistic regression performed best at 75% accuracy, while also confusion matrices highlight misclassifications and areas for improvement. Next slide. In conclusion, for the model evaluation comparison, I would say that we compared the naive bias, random forest, and logistic regression, with logistic regression achieving the highest F1 score of 0.75, and confusion matrices show it best balances precision and recall, making it the most suitable model for the dataset. Now I'll walk you through the Python code that we have used to do the model evaluation and prediction. So here we have given the description of the dataset, and also we have tried linear regression and different test models, and we have predicted the features. So this is actual versus predicted performance for the athletes. And next we have a chart for a bar chart showing the each post session performances. Also, these are the decision trees that I mentioned for S1 performance, and also we have a decision tree for S5. Yeah, here is the decision tree that we made for S5 communication abilities post. This is the heat map that we did for athlete performance versus the predicted differences. Next, Python file for model comparison. In this Python file, we have compared three different models, that is random forest, naive bias, and logistic regression. Here you can see logistic regression performed very well with 0.75 accuracy in this bar chart. Can you scroll down, Mehak? Yes, here you can see the accuracy, precision, recall, and F1 score displayed for each method. And this is the confusion metrics for each method. And here we can see the differences between the features. And also we have created different bar charts, column charts for the features that we found in random forest, linear regression, and also in naive bias. So in conclusion, I would say that here logistic regression showed a greater performance when compared to other three models. That's it. And over to Shamli for further explanation. Thank you.
Thank you, Darshana. So here is the test dashboard using Power BI, which demonstrates CSA sports performance. It provides interactive analytics on athlete performance. Future iterations will enhance the engagement and tracking. Next slide, please. Challenges and proposed solutions. Our challenges were having limited data set. There was confusion in tool selection. We had poor model accuracy and then lack of engagement in initial dashboards. The solutions we wanted to propose were using historical data. We finalized Power BI. We improved feature selection and added interactive elements to the dashboard. Next slide, please. Our current recommendations is to refine predictive models, enhance data preprocessing, implement interactive dashboard features, and align with the client expectations by refining key performance indicators. Next slide, please. So far, our communication with client was great. We still want to maintain client engagement through feedback and iterative improvements and ensure predictive insights align with the client goals for the better usability. Over to Arjun. Thank you.
Thank you, Shamli. So now here we have a Jupyter notebook, which is analyzing the project cost using Python. And we have used Excel file to categorize project cost into theoretical cost and current spends and calculate phase-wise cost. The bar chart visualizes the theoretical cost distribution across project phases. As you can see, the labels indicating values $50 and $600. So the theoretical cost is calculated as $650, which is also uh, to the back Mech, yeah, as the $650, which is also displayed at the bottom, as you can see. Next slide, please. So here we have done the analysis of project cost using bar charts. The left chart shows the projected cost to completion for different tasks, while the right chart illustrates the current spend by phases. So the total current spend is $2,300, and the estimated cost to complete the project is $1,750. So as mentioned, like in the bottom, if you can see, the insights help track budget utilization and future financial requirements. Can you go to the Jupyter file, Mehak? Yeah, so this is the Jupyter file for the code. So as you can see in the in yeah, over here, as you can see, like the project initial phase cost us around $600, but the project mobilization phase like cost around $50. Second one, yeah. So here we have like spent it on different by like different phases. So the requirement phase cost us around 650. The design phase cost around $1,350, and the model evaluation phase cost us around $450. The dashboard development phase cost us around $150. So the least was cost us about the $150, which was by dashboard development phase. And these two data we took it from the timesheets, so which help us to identify the current data. And the last one, if you see over here, this is the code where we projected like cost by different tasks. So like the as I've mentioned before, the dashboard development phase, it cost us around $650, which was the highest, and the testing and iteration phase cost us around 600. The final report preparation phase cost us around $500. Can you go back to the PPT, man? Yeah, so here, so we have like the next steps and the final deliveries. So now we have the client review. We are awaiting for the final feedback on our predictive insights and the dashboard refinement, enhancing usability, integrating final feedbacks, the final model improvements, where we have to adjust ML models for better accuracy, and the project completion. So the final report and the deployment plan and the final report has been planned for the next phase. Next slide, please. So, as per the conclusions, the project is progressing well, particularly in data analysis and dashboard development, which is keeping it on track. So, however, the predictive modeling needs further refinements to improve accuracy. Client engagement has been positive, and we are currently working on the final iteration to ensure project completion. Thank you.